Measures of dispersion are another important statistic that we use when describing a set of data or a data distribution. Before I show you some data and start describing problems, I'd like to talk about a couple definitions that you may have found confusing. I'm going to give you an example where I talk about the length of my pinky. And if I were, let's say, to measure the length of the pinky of everyone in our class, I could calculate a mean and I could calculate a standard deviation. However, we would call those values sample statistics. Why sample? Well, it's because they are of a small subset of all people who have a pinky finger which has a measurement. Might they be very close to the actual average of everyone in the world? They might, but it's more likely they're not. That's why we call it a sample statistic. I made a little chart here, and I want to show if we were to calculate the mean of, let's say, the length of 28 people's pinkies, we would abbreviate that mean as X bar. We did that last week when we were calculating sample mean, and of course that continues this week. If we were to calculate the standard deviation, which, as you've learned by now, is one of our key measures of dispersion in the data, we would use the symbol S. However, if I had measured the length of the pinky of everybody in the world, and so it was no longer a sample statistic, but it was a population statistic, then we would use a different symbol. For mean, we use the symbol mu. I'll spell it. Mu is a Greek symbol. And likewise, for standard deviation, we use the symbol theta. Theta. Another letter from the Greek alphabet. So, in your text, you will see both of these terms thrown around. Usually, we assume that we have population statistics and we can use these values without worrying about violating rules of statistics, although sometimes what we're really given are sample statistics. So keep in mind, mean, we're either talking the sample statistic, which we abbreviate X bar, or the population statistic, mu. They both mean the mean. Similarly, for standard deviation, S or theta. Okay, let's move on and talk about a population. Let's talk about pinky length. Let's assume I've measured a lot of pinkies. And let's see, I'm going to draw a number line here. Let's see, these are the number of inches. And let's say, I measured the pinky length of, 10 or 20 people. And gee, I found a whole bunch of them. We're right at 2 inches. There was a whole bunch at whatever this is, 1 3/4 or something. And there were a bunch at 2 1/4 or whatever that is. And the further I got, as I continued to measure, I found there were fewer and fewer a distance away from what appeared to be that central measure. Let me just fill in my pinky dots here. Let's say I ended up with a distribution like that. This looks like what we term a normal distribution. And a normal distribution is one type of statistical distribution that is very common in nature. It's very common in biological measurements, but it's also common many other places. Now, if we were to draw a curve that encompassed these data, we might draw, oh boy, not doing a real good job, but that's okay. We might do something like that and create what's called the bell curve for the normal distribution. There are several unique things about this curve. First of all, also let's now assume that I've calculated the mean, and the mean is 2 inches. We would find that the mean, the median, and the mode all equal 2. And that's just one of the unique things about the normal distribution. It's symmetric about the mean with an equal number of values on either side. Oh, and there's a couple other unique things that I'll redraw this. The point I want to make, though, is that in much of our statistic work, in much of the calculations we make, we assume that there's a normal distribution. And the author didn't really talk about this too much, but be careful if you're using this at work or in some other case, because if a distribution is not normal, if it's one of those with several modes or a long skewing tail, then the statistics that we have must be modified. Calculating standard deviation, mean and median and mode will no longer be the same, and you have to be very careful. And that's the time where maybe it's time to talk to a statistician. Okay, let's continue with this in the next video.